स्टूडेंट्स, तो कैसे हैं आप लोग। आज हम पढ़ेंगे ड्रिफ्ट वेलोसिटी के बारे में। क्या होती है ड्रिफ्ट वेलोसिटी? ये करंट इलेक्ट्रिसिटी का एक इम्पॉर्टेंट पार्ट होता है। इसमें हम क्या करते हैं, इसकी डेफिनेशन में द वेलोसिटी विद विच इलेक्ट्रॉन ट्रेवल inside a conductor on applying इलेक्ट्रिक फील्ड। ठीक है, तो इसे हम समझते हैं होता क्या एक्चुअल में। जैसे आपका एक कंडक्टर है, इसके चारों तरफ अगर एक हम बैटरी कनेक्ट कर दें तो यहाँ पे पोटेंशियल डिफरेंस जनरेट होगा। पोटेंशियल डिफरेंस कैसा होगा, ये प्लस और ये माइनस है, तो ये वाला आपका प्लस और ये वाला माइनस। तो आप सभी को नॉलेज है कि इलेक्ट्रिक फील्ड इज फ्लोइंग फ्रॉम पॉजिटिव चार्ज टू नेगेटिव चार्ज। तो इलेक्ट्रिक फील्ड फ्लो लाइक दिस। तो इसके अंदर जो भी इलेक्ट्रॉन होगा वो अंडर इन्फ्लुएंस ऑफ इलेक्ट्रिक फील्ड आ जाएगा, और ये इलेक्ट्रॉन है नेगेटिवली चार्ज है तो ये पॉजिटिव की तरफ अट्रैक्ट होगा। ओके, तो ये इलेक्ट्रिक फील्ड अगर ई है तो फोर्स ऑन पार्टिकल कितना आ जाएगा, इलेक्ट्रिक फील्ड इनटू चार्ज। सो एज वी नो, हम फोर्स से क्या निकाल सकते हैं, एफ इक्वल टू एम ए, क्लासिकल मैकेनिक्स का है, मैकेनिक्स में आता है ये। तो हम बोल सकते हैं एक्सेलरेशन बराबर फोर्स अपॉन मास। तो वी कैन से हियर एक्सेलरेशन इज इक्वल टू चार्ज ऑफ इलेक्ट्रॉन, इलेक्ट्रिक फील्ड डिवाइडेड बाय मास ऑफ इलेक्ट्रॉन। दिस इज इलेक्ट्रिक फील्ड, दिस इज इलेक्ट्रॉन का चार्ज, दिस इज mass of electron. So we can deduce this is as an acceleration which is acting on the electron due to electric field which is generated due to the potential difference. Now we understand, let this is an electron and there is an adjacent electron which is nearby to it. When electric field is applied, the electron is accelerated towards it, but the electron can do this much motion without any interference. Up to this much motion, it take time t to travel this distance, and after which it collide to the next electron. So the energy of this electron will transfer to this electron, and so on. This electron will go like that, and this will collide to this electron, and again the energy will transfer to this electron, and so on. The motion is going on. Hence, the no electron is exactly moving from its position to this position. They are only vibrating from about their mean position. Hence, the net motion, the net displacement of each electron is 0. So, up to time t, the electron can do a free motion. So, this time is called as relaxation time, and this is denoted by tau. So, we can say the velocity gain by electron in tau time will be v is equal to u plus at. Here the initial velocity is 0 because electron is at rest at the initial time. So v is equal to your acceleration charge of electron e me upon tau. So the velocity gained by the electron is called as drift velocity, and we will denote as a vd is equal to e electric field tau upon mass of electron. This is called drift velocity. So now I am going to prove Ohm's law. Ohm's law. So first we draw a wire. Let there is n number of electron per unit volume. Okay, let's choose a segment dx in this wire, and the area of cross section is a. Okay, so the volume of this region will be a into dx. So the number of electron in this region will be a dx into capital, I can easily write it n a dx. Okay, number of electron per unit volume is n, and the number of electron in the given region is na dx. So the charge will be E n a dx. I hope you understand it. So as we know, the current is I is equal to what? Dq by dt. So here we can write E n a dx divided by dt. So I will be equal to E n a dx upon dt. So as we know, dx is a very small term, so dx by dt is can be equal to vd, drift velocity. So I can write I is equal to nea vd. This is your expression for current in a wire. Now I am going to ask some question to you, some basic questions to you. Let there is a wire which is varying in area like this, conical wire. This is point A, this is point B, and this is point C. The area of ABC is as per the given diagram. You have to find what? Velocity of A is equal greater than velocity of B is equal to velocity of C. B, velocity of A is less than velocity of B is less than velocity of C. Sad option, velocity of A is equal to velocity of B is equal to velocity of C. Or D option, velocity of A is equal to velocity of B is greater than velocity of C. Which of the following statements are correct, and V is your drift velocity at the given instant? So we notice this is in series. If you connect this wire along a battery, the whole wire is act in a series. So we can say the value of I will remain the constant. So I is equal to NEA VD. So from here we can get I is proportional to A into VD. As I is constant, we can say VD is inversely proportional to 1 upon A. So we can easily conclude the area where the area is more, the velocity is less. So maximum area is AC is greater than AB is greater than AA. So we can say velocity of A is more than velocity at B is more than velocity at C. The option 1 is your correct. I hope you get it. So now we are going to prove Ohm's law. Here we had deduced that I is equal to NEA VD. And as we know, VD is equal to EEME into tau. By putting this in the given equation, we can write I is equal to NEA E tau upon ME. So we can get NE square A E tau upon ME. This is your correct. This is your current. We now understand electric field is generated due to the potential difference, and we know E dot dx is equal to minus of dV. The minus sign represents the sign of the minus sign represents the direction of potential or electric field. So we can easily write E into L is equal to V, or we can say E is equal to V by L. So putting this in the previous equation, we can get I is equal to NE square A tau V by ME into L. So we will take this whole of the equation to this side, this much equation to this side, because we know V is equal to IR. So we will write it as MEL I divided by NE square A tau is equal to V. As we know, mass of the electron is constant, L is depends upon the size of the rod, N is depends upon the material, charge of electron is also a constant quantity, A is depends upon the size of the, and tau is the property of the material. So here we can say MEL NE square A tau is a constant term. So we can write MEL I divided by, what is this? NE square A tau is equal to V. So we will write this constant as R. So R is equal to MEL and E square A into tau. So we will rewrite this equation as V is equal to IR. This is your Ohm's law. Here we can say R is equal to M NE square tau L upon A. So we can notice further, this is also a constant term which depends upon the material, because mass of the electron is always constant. number of electron per unit volume is always a constant, is charge of electron always constant, tau depends upon the material. So it is also a constant, so rho is equal to m e upon n e square tau. So this is called as resistivity, and we will write is at I r is equal to rho L upon A. This is your resistance. So thank you. This is the proof of Ohm's law. If you have further any doubt, please comment and write it. I will try to solve your doubts. Thank you.